Hello and welcome back to the Algebra 2 PLC around Unit 3, an introduction to trigonometric functions. I'm James Key with the MCPS Math team, and I'm here on the set of Homework Hotline Live. In this segment, we'll take a more in-depth look at the tasks in Topic 1. Let's go ahead and take a look. So in Task 1, students are presented with a Ferris wheel, and they're asked to determine the height of each chair shown in the diagram. They're presented with the information that the center of the wheel is 30 meters high, as well as the fact that the radius of the wheel is 25 meters. So as an example of how students might reason about this, to determine the height of this first chair right here, we can obviously infer that if the center is 30 meters up, and we've got that covered, and we just need to describe this additional height right here. Students can determine the measure of each of these angles right here, and then they can use their knowledge of right triangle trigonometry that they developed in the geometry course to write that the sine of that angle is equal to the ratio of the opposite side to the hypotenuse. And then they can calculate the value of the height using that relationship. Add it to 30, and they've got the distance off the ground. And they can do that for each of these locations. In Task 2, the discussion is then extended by bringing in a component around time. And they're presented with the information that the Ferris wheel completes a full turn in 20 seconds. And so they can figure out how long it would take to reach each of these locations, and in general, write the height of this particular chair as a function of time. And they come up with an expression for that. In Task 3, students extend their understanding of the definition of the sine function. Again, in the geometry course, they have a limited view of what the sine function can do, limited to the right triangle context. And so their prior knowledge would involve this definition. Sine theta is the opposite leg divided by the hypotenuse. However, in trying to describe the height of a point as it moves around a circle, we need a broader view of what the sine function is and what it does. For example, thinking of this red point as having moved not at all through 0 degrees, we'd like to be able to describe its height after a rotation through 0 degrees. We'd like to describe its height after a rotation through 90 degrees. Notice that neither of these is admissible in a right triangle context. We'd like to be able to describe the height for values that are greater than 90, 180 or greater, 360 or greater. Again, this old definition is no good for any of those tasks. So ultimately, students are led to what we know is the standard definition of the sine function, which involves the coordinates of a point on a circle of radius r. And so they're led to this understanding right here. If we rotate through theta degrees and land at a point whose coordinates are x comma y, we can define the sine of theta as the ratio of the y coordinate to the radius. Noticing that one of the things that can come out of this extended definition is the fact that the sine function might return 0, it might return 1. In the example shown here, it might return a negative value. Again, none of those things can happen with the old way of thinking about the sine function. In Task 4, students look at the relationship between the features of the Ferris wheel and how those features show up in the graph that shows height against time, as well as how that shows up in the equation. There are animations with sliders that students can use to explore what happens if we increase the height, increase the radius, or increase the length of time that it takes to complete a full cycle. In task 5, we set aside thinking about height and horizontal motion to a task that requires students to think about horizontal motion rather. In particular, students are presented with a situation where the sun is directly overhead, and so each chair is going to cast a shadow at a certain location, and we can describe where that shadow is in relation to this line of symmetry using the cosine function this time. Okay, this has been a look at the tasks in Topic 1 of Unit 3. Again, if you have questions about the curriculum, please feel free to send those in at any time to mcpsalgebra2plc@gmail.com. In the next segment, we'll begin to look at the tasks in Topic 2 of this unit. Thanks for joining us.